היי!
שלום לכולם, ואיזה כיף שבאתם לאירוע של JavaScript ישראל. היום יש לנו אירוע שהוא ממוקד לסקיוריטי עם דוברים מהממים, וזהו, אז יאללה, בלי יותר מדי מילים והקדמות בואו נתחיל, אבל בכל זאת יש טיפ על ההקדמה שאני צריכה לעשות. אז אני רק רוצה להזכיר לכם שיש רפל, בסוף אנחנו מגרילים פרסים ממש שווים, ממש שווה להירשם וממש שווה לחכות לו. דבר שני, אני רוצה באמת להזכיר לכולם שאנחנו ממש תמיד אוהבים לראות דוברים חדשים, אז זה הכתובת, כאילו זה ה-URL להגיש באמת CFPs כשאנחנו מפרסמים אותם, אז יאללה, לכו על זה, תגישו, ואנחנו ממש נשמח לראות אתכם מדברים בקהילה שלנו. אני רוצה להזכיר לכם את ה-Code of Conduct שלנו, לגבי התבטאויות מסוימות, והתבטאויות שמכבדות אחד את השני. סומכת עליכם חבר'ה. טוב, אין יותר מדי דברים מעניינים שקורו ב-JavaScript תקופה האחרונה, אבל אני ממש רוצה להודות לספיקרים המאמנים שלנו, להודות למרק מילר, לעידן, ללירן ולג'וש, וכמובן ממש להודות לספיקר בדיז שעזרו לנו ועברו על המצגות, כרגיל ספיקר בדיז עבודת קודש, אין עליכם. אז בלי יותר מדי, אני רוצה גם דבר אחרון להודות לטרקס שעושים ספונסרשיפ לאירוע הזה, ובאמת בזכותם יהיה וידאו, ותודה רבה לכם, אחלה מקום מגניב, וזהו חבר'ה, אני אומרת שבואו נתחיל. אז בלי יותר מדי, אני מאוד רוצה להזמין למה את ג'וש, הדובר הראשון שלנו, והוא בעצם מפתח בטרקס. ג'וש, מה העניינים?
מה קורה? טוב לחזור לפה, מה קורה?
הכל מעולה, אז יאללה, אז בואו נתחיל בהרצאה הראשונה. ההרצאה הראשונה על נושא של סקיוריטי, של רייט לימיטינג. אם אתם לא מכירים, ג'וש יסביר לכם הכל על זה. בהצלחה ג'וש.
תודה, רואים את המסך נכון? אוקיי, מעולה. אז ככה, כן, קוראים לי ג'וש, אני ראש צוות Web Applications בטרקס, and now I'm going to switch to English because I understand that all the lectures today are going to be in English, so I'm going to take the opportunity. Okay, so I'm going to spend a few minutes speaking about API rate limiting, but first of all, Trax, who are we? What do we do? So Trax is the world leader in computer vision solutions for retail. Okay, we provide solutions to digitize the physical world of retail, and we work with some of the biggest brands, for example, Coca-Cola, Colgate, Del Monte, even Google, Mars, and almost 200 other brands. Okay, and we work at a really big scale, 140 million items are scanned monthly, 12 billion items of recognitions to date, and 15 million stores are digitized daily. So we work at scale, and it's really important for us to work consistently and reliably. So how do we do that? So one of our tools that we use is rate limiting. Okay, what is rate limiting? So it's basically preventing the frequency of an operation from exceeding some constraint, and it's done in order to protect underlying services and resources. So just a quick example, you can rate limit requests to an API such that there are no more, I'm just making this up, 1,000 requests per second in order to protect the underlying services and resources. But why would we want to do that? What do we want to protect these services from? Okay, so 3 examples here. First of all, denial of service attacks. For example, okay, imagine you have an attacker who's sending multiple requests to a victim server, trying to overwhelm it and bring it down. So here you have many requests being sent. Number 2, brute force password guessing attack. So you can have someone who's trying all the different combinations of a password in order to try and guess a user's password. Again, many requests are being sent. Number 3, even if there's no malicious intent, you can have your servers being overwhelmed by many requests being sent by your consumers. So in each of these situations, you want to rate limit the requests being sent such that they don't overwhelm your service and you can deal with it. better for your security. And it's actually this third case that overwhelmed servers, not malicious intent, that was specific for us at Track. So we had one consumer who was sending so many requests it was overwhelming our services. So we had to implement a per client rate limit solution, which hopefully I'll get to in just a couple of moments. Okay, so when we talk about rate limiting implementation, so where can it be done? So you can see here some very simple architecture. You have a few clients sending API requests. The API gateway is then directing these requests to the relevant microservices via the load balancer. Okay, so the truth is you can actually do rate limiting in every single stage here. You could do it in the client, the API gateway, even the load balancer, and also the microservices. But I want to concentrate on the two specific places, which are the API gateway and on the microservices themselves. Okay, so rate limiting on the API gateway is pretty high level, and that's an advantage because it covers every single endpoint altogether. And another advantage is that the requests can be limited or stopped before consuming the server resources because the requests don't actually reach the microservices. And it's also pretty flexible. If I take the example of the API gateway and AWS, so you can configure rate limits per resource or per method or per API key. Pretty flexible, but is it enough? Okay, and I asked that, and we'll see why in a moment. The other place I want to take into consideration is rate limiting on the microservice itself. Okay, so you can do it within the code. For example, you can use a middleware package within Express, like Express Rate Limit. Okay, it's pretty simple to set up, just a few lines of code. It's extremely flexible. Okay, you can change the configuration as you want. In many different cases, you can make it responsive. Okay, but the disadvantage of doing within the code, actually there's two disadvantages. Number one is you have to do it per microservice as opposed to API gateway, which is high level at the top. And also it uses the service resources because the request has already reached the service and so it has to deal with it. Okay, so having said that, we can see that it's clear that API gateway is the ideal position to establish the rate limiting. So the question is, why would you consider doing it within the microservice itself? Why would you consider writing it as part of your code? Okay, so I'm going to give two examples as to why you would do that. The first one here you can see is different customer plans for a software as a service website. And if you compare the different plans, you can see that there are different limits per the type of plan. So, for example, the free plan had 100 queries per month, limited to a rate of 1 request per second. If you compare that to the business plan, they have 750,000 requests per month or queries per month, at a rate of 50 requests per second. So the API, the rate limiter has to be extremely flexible to understand who the customer is, what kind of plan they have, in order to correctly rate limit their requests. In actual fact, if you take a look at the enterprise plan here, there's no rate limiting at all. So it has to be able to deal with that too. So trying to implement that on the level of the API gateway is extremely difficult. It's easier to do that within the code. Okay, another example is what's called responsive load shedding. So you see here on the right-hand side, you have a couple of microservices that are sending a request to a third microservice. This third microservice might get overwhelmed with the amount of requests they have, and it's not able to properly serve its consumers. Now imagine one of the consumers is a high-priority microservice sending high-priority important requests. So because of the load on the third microservice, it's not able to send its requests through. So a solution for that is by rate limiting. You can rate limit the low priority microservice such that the high priority service continues as normal. It's able to serve the request as necessary. And then once the third microservice service, this serving microservice is, the load goes down, then the low priority service rate limit can be stopped. So it can be responsive, and that's what responsive load shedding is. It can shed loads, in other words, stop loads responsively depending on the state of the system. Okay, in the last minute that's remaining, I just want to give a simple code example now that we understand why we would want to do it in the code. Okay, referring back to the package I said before, the express rate limit. I've taken this code from their NPM page, so it's really simple code. You require to the actual package, then you configure the rate limiter such that you have a time window of 15 minutes in this example, with a maximum amount of requests of 100, and then this rate limiter middleware is applied to all requests. And what happens is that when this instance receives a request, it checks to make sure that there are no more than 100 requests from this IP, from this client, within that time window of 15 minutes. If there isn't, then obviously it goes through as normal. But if there is more than 100 requests within this 15-minute time window, then it will return a 429 error, which is the correct response status code for rate limiting. Okay, and then when the client receives this code, they'll be able to know and understand how to act in a relevant way. Okay. The problem with this code, though, is that as I said before, it's not on the microservice, but on the specific instance. Now, imagine you have a load balancer sending requests to different instances of this microservice. They're not going to know how many requests have reached the other instances because this is in memory. It's counted in memory. So how do we solve that situation? It's very, very simple. There's a second package that's called rate limit Redis, which is a Redis store, and you can configure this rate limiter just to use a store. As long as each instance is connected to the same Redis store, they can each calculate how many requests have been sent from this IP from this client. And it doesn't make a difference which instance this request was sent to, or which instance they were dealt with. As long as it knows and it can count how many you have for all instances, then the rate limiter can apply and work as necessary. So that's it. That was just a very few minutes on rate limiting. Thank you very much for listening.
תודה רבה לג'וש, בהחלט החכמנו לגבי rate limiting, היה ממש מגניב. ועכשיו, מכיוון שהדובר הבא שלנו מגיע מארצות הברית, I would like to present you Mark Miller, first of its name, and he would talk about how to use SES to reduce the supply chain risk. Mark, good luck.
Okay, thank you. Okay. Yeah, I'm Mark Miller, Chief Scientist of Agoric, and I have been on the ECMAScript Standards Committee, this committee that standardizes JavaScript, since 2007. Today I'm going to talk about using SES, secure ECMAScript, to reduce supply chain risk. Any discussion of supply chain risk should start with the event stream incident. In the event stream incident, the maintainer of an NPM package named event stream, just a general purpose, low-level utility, published an upgrade of the package that contained a targeted attack on the BitPay cryptographic wallet. The BitPay wallet was an application written in JavaScript in the same way that a zillion other applications are written in JavaScript. A small amount of code which constitutes the application itself, and then importing package dependencies on a bunch of other packages that in turn had dependencies that sucked in this whole graph of other packages, all of which were linked together and running in the same JavaScript environment. NPM reports that of the typical JavaScript package, only 3% of it is code specific to the package. The 97% of the code that's linked together are other third-party packages that you don't have any particular good reason to trust. This dependency graph here is from MetaMask. The purple dot that has the great fan out is MetaMask itself. All the rest of these dots are other packages in their dependency graph. And if run under normal JavaScript in the normal way, all of these dots would be red. What we mean by red is red versus green is a measure of the risk that you have from the package. In normal JavaScript, anything can damage everything. Everything is fully vulnerable to anything. And that's why all of the dots would be red. MetaMask uses SES to partition risk, to give each package only the least authority needed. Follow the principle of least authority, of give each package only the authority it needs to do its proper job. However, some packages still need significant authority to do the proper job. Most of it's green. Most packages need very, very little authority and can be verified to need little authority by static analysis. But the ones that are red are the ones that still need a dangerous amount of authority to do their job. So that's the place to focus security review effort. By running all this code under SES and by doing this analysis, we can focus our precious time in security reviews to the code that actually poses danger to us. And we can substantially reduce the danger posed by the other code. So why is it that in JavaScript, everything is fully vulnerable to everything? A good example is the attack of prototype poisoning. The primordial objects are the objects like array.prototype or the array.prototype.push method that all the arrays inherit. That are, the primordials are the ones that exist before code starts running. And in normal JavaScript, all of the primordial objects are fully mutable. So any code can, for example, replace the array prototype push method, changing the behavior of all of the arrays created by all of the other packages that have been linked together. So the first defense that SES brings is it freezes all of the primordials. It turns all of the primordials into transitively immutable state, where there's no more mutable state left anywhere among the primordial objects or ability to do I/O. The other source of attack is through the shared global object. All the code linked together all share one global object, and the global object is also the one that contains the host objects, like the document object in the browser. Each host, each context that JavaScript runs in provides some powerful global objects that provide the ability to do I/O to the outside world. And because everything runs in the global scope, everything has access to all of that power. So SES introduces an abstraction called the compartment. The compartment creates separate global objects and separate global scopes inside the overall JavaScript system. And what we in fact do is we run each package in its own compartment, and we endow that compartment with only the globals that that package needs. So over here, we have a compartment C1 that is unendowed with anything, and the expression x plus y evaluated there just gives a reference error because there are no x and y globals. C2 is a compartment that's endowed with global variables x and y that have a different value, and x and y run in there gives a result. So how did we get from normal JavaScript to SES? The main thing about our approach is that it's subtractive. It's mostly subtractive. When I started in 2007, ECMAScript was this incredibly messy language with crazy constructs like the with construct that provided non-static scoping, or other constructs that provided non-local causality, action to distance. So the first thing we did with ECMAScript 5 is we introduced strict mode. And strict mode is a sublanguage that is mostly designed to omit all of the most crazy parts of JavaScript. However, even strict mode has these problems that make everything vulnerable to anything. All of the primordial objects are mutable. There are these host objects that are accessible to everything because they're bound to global variables. And there's that per realm global object, everything sharing one big global object. SES makes the primordials pure, removes all mutable state or IO, and introduces the compartment to create per compartment global scopes and global objects. But the important point here is that the change from ES strict to SES is so minor that a tremendous amount of old code, of old JavaScript code not written to run under SES, nevertheless does run successfully under SES. And that claim is borne out by experience at a number of different companies. All of these projects are using SES. In the right-hand column is JavaScript for embedded systems. SES is the standard JavaScript for embedded systems. And Moddable makes a engine for embedded that out of the box is an SES machine. And they're running it even on light bulbs, and even on light bulbs making use of the security properties of SES. And these security properties are sufficiently strong that they even provide some degree of mitigation, some degree of defense against side channels. It's not the main target. The main target is integrity, is reducing authority, ability to cause effects. But the observation about side channels is all these side channels that people worry about, including Meltdown and Spectre, all rely on the untrusted code, the attacker code, being able to measure duration. Those green dots visibly don't, most of them don't need any of the objects that would enable them to measure duration. So under SES, we can deny them the ability to measure duration. So over here is a shot of the SES challenge page, in which we provide a side channel, a very loud side channel that is leaking a secret. And it's sufficiently loud that it's easy for code written in SES, but provided with the powerful date object, a date object that reveals the current time and therefore enables measurement of duration. It's easy for that code to read the side channel and thereby figure out the secret. With the same page, if you turn off the power of the date object, so the date object is no longer providing the ability to measure duration, it still provides the ability to represent dates, to parse dates, to print dates, all of that, then we challenge you to write code in the presence of this incredibly loud, easy to read side channel. If you can measure duration, we challenge you to write code that will nevertheless figure out what the secret is. So how does this work? Well, we talked about the compartments being able to be endowed with different globals. The C3 compartment is created with no endowments. A compartment by default has almost all of JavaScript, has all the global variables defined by JavaScript, has essentially all of the properties and all of the methods defined by standard JavaScript, which is why old code still works. But the date object is a safe, that's provided by default, is a safe variant of the date object, where date.now gives nan. However, depending on the switch you flip on the challenge page, if you provide the powerful date object, the way the code does that is the code running in the start compartment, the code that's running in the global that you're starting with. It's sort of in the implicit compartment before any other compartments are created. That has all the powerful globals. So when that makes another compartment, it can endow the other compartment with the powerful date, in which case the attack can work because the attacker can read the date. Let's go into that in a little bit more depth to understand in detail how SES does surgery on the normal JavaScript environment in such a way as to provide strong safety, but with a minimal impact on existing code. The graph you see here is a sample, is a representative sample of some of the objects in the primordial JavaScript heap. And the arrows here are how they're wired together. The vertical arrow is inherits from. Let's first of all just remove the obvious inherits from the graph. All functions inherit from function.prototype, so we don't need that noise. And in addition, there's the primordial global object, which we're going to treat specially. The global object has global variables, which are alias to properties that point into this primordial heap. And it has a global this variable that points at itself. And some of the objects in this primordial heap have a special status. They are evaluators. They evaluate code. Code has to be evaluated in some scope. So the evaluators evaluate code in the scope of the global object. The global object also has these host objects, like document or XML HTTP request, or in Node, the process object, in XS running on a light bulb, the ability to turn the light bulb on and off. All of these come in as host objects. And the host objects are dangerous by design. They're intended to provide I/O. And date, as we've seen, is an outlier of the JavaScript heap. It's one of the rare objects standardized by JavaScript that provide this I/O ability to read the current time. So because those objects are dangerous, the global object itself is dangerous. Because the global object is dangerous, the evaluators that evaluate code in the scope of that global object are dangerous, because now that code can reach the dangerous objects like date and document. So what we need to do, what SES needs to do, is do surgery on this graph to partition the safe versus unsafe worlds, and to do it in a way that has the minimal impact on existing code. So we pull off all of the unsafe objects into the graph on the left, representing the start compartment, and the graph on the right are the frozen primordials, the frozen shared intrinsics, which are pure, which have no mutable state, and that are safely shareable. And the key thing is to notice is that between these two subgraphs, the only arrows that cross between them are going to the right. The start compartment subgraph points into the intrinsics, and there's no pointers in the opposite direction. The two dates, the date in red on the left is the original powerful date. The white date that remains in the frozen intrinsics is a safe variant that has all of the ability to represent dates, date instances, and to do formatting, etc., but not to provide the current time. So because all of the arrows cross only rightward, we can create other compartments where the other compartments also point into this graph in a similar manner. And then we can run old code in the scope of that compartment. And because the evaluators evaluate code in some global object, each compartment has to have its own evaluators. It has to have its own global object, but it doesn't have to have much else that is per compartment. So these compartments are really featherweight. They cost creating a few objects per compartment. So you can have many, many little compartments at very little overhead. The code that creates compartments can also endow the compartment with emulated host objects, or attenuated host objects, with host objects that the start compartment wants to endow the other compartment with, such that the code in the other compartment thinks it's running in a normal JavaScript environment, except that the primordials are frozen, but it finds on the global object that it sees as global whatever host objects were endowed by the creator of that compartment. And the compartment abstraction itself is made available. And it's, as we've seen, has an evaluate method. So the compartment abstraction is itself an evaluator. So in addition, each compartment has its own compartment constructor. And that is the brief overview of SES. For more information about SES and what Agoric builds on SES, Agoric is building a smart contracting platform that runs on both blockchains and non-blockchains and provides distributed secure SES built on the SES that I've explained. So all of those are explained at agoric.com. And the particular challenge that we invite you to take to try to read that side channel is at that URL. And now I'll take questions.
That's a cool question. All right. I see that there are no questions, but well, maybe people are shy. Maybe there would be questions. Otherwise, Mark, thank you for the excellent lecture. It was a pleasure to host you here. Oh, wait a minute. Sorry, there is a question. All right. Sorry. Benjamin Greenbaum wrote a question about how do I use this? Can you please elaborate, Mark? I see that there are a bunch of questions here. Sorry. So let's start with Benji.
So I would start by taking a look at the source code for the challenge problem. And there's many pages that are linked to from agoric.com. There's other URLs that I can post, which I hope that you can relay to the group, that gives you good starting points for using SES. But essentially what's going on is that SES has both the status of being a secure shim, which is how we're currently using it on browsers, on Node, in other environments. So it's as a shim, it's just a library that you load to get things started in a base JavaScript environment. And it only depends on the things that are part of standard JavaScript. So any system, whether browser or Node or something else, that provides a JavaScript engine that conforms to the full language should be able to run our shim library and to use it in a secure manner. And all of those organizations that I mentioned are using the except for embedded are using the shim. The embedded use is using the XS engine, which directly builds SES rather than using the shim. Which actually it's some of the mechanism currently does come from the shim running on top of their engine, but it's more of a mixture. And then once you're in the SES environment, you're still running in the start compartment that has all of the fully powerful globals that you're used to. But from there, you can create other compartments. Now, in order to use it to load in a graph of other packages and analyze those other packages for least authority and link them together by least authority, the system to look at is in particular Lava Mode and MetaMask. And Agoric is in the process of integrating Lava Mode in with the overall SES distribution. And it's Lava Mode that will automate most of the work of linking together a dependency graph of packages while doing the static analysis to see what authority do they obviously need, and then to arrange things to give them only that authority.
All right. Now we have another question from Idom again. And he's asking, is it relevant in Angular apps where security is mostly baked in?
I'm sorry, the audio, your audio is muffled.
Yeah. So Ida is asking about combining SES in Angular apps.
I'm sorry, combining SES and what?
In Angular.
Oh, Angular. Yeah. No, I do not believe that has been a successful integration. The restrictions that SES requires correspond very closely to recognized JavaScript best practices. The main way in which some old code fails to run under SES is if it modifies the primordials. Like the example we showed of array.prototype.push assigning an attacker function to that. Well, that example was preventing an attack, but some code does some surgery, some systems do some surgery on the primordials in startup in order to get some deeper integration into JavaScript. And SES treats that as an attack and prevents it. So while there's much old code that does run under SES, anything that does that level of surgery on the primordials does not.
All right. Well, Benji wants to mention the cheat code is very interesting JavaScript to read.
I'm sorry, your audio is still muffled. I'm really having trouble understanding you.
Oh yeah, just Benji is mentioning the cheat code is a really, really interesting piece of code to read. That's what Benji is saying. Yeah, definitely. All right.
Well, thank you for we also invite everybody to read all of our code and to comment on it and to point out bugs and to send us pull requests, whatever. Everything that we're doing is completely open source. It's all on GitHub, both SES itself and all the things we're building on top of it, all the way to our blockchain-based smart contracting system. And most of the other projects on it are also fully open source.
Cool. So that was an amazing lecture. Thanks a lot.
You're welcome.
Thanks a lot, Mark. It was a pleasure to host you here.
Yeah, pleasure to be here.
Cool. All right. So I hope that Idan is getting ready. Idan, are you ready? I think you're muted.
I think you can hear me now. I hope you can hear me.
Now we can hear you.
Excellent.
Cool.
Yeah, I'm ready.
So, אז עכשיו אני מזמינה הבאה את עידן, שיספר לנו, שיספר לנו איך טעות אחת קטנה בקוד שלו בג'אווה-סקריפט עלתה $8,000?
I'll show you in a second.
אז עידן, first of its name, קדימה.
Thank you, and I want to give a special thanks to JavaScript Israel and Trax for sponsoring this, especially at this time. Events for the coding for the developer community is super important, so thanks a lot, and thanks for having me. And so my name is Idan Cohen. I'm a front-end lead at UVI. What we do here is we scan vehicles, and we use AI to analyze the results, some really cool stuff. But today I want to talk to you about something that could never happen in UVI. It happened on a side project I'm doing, which is something I recommend all of you to do. It's a great place to try out new technologies and get your hands dirty with some real-life examples and use cases. In my specific case, my side project is an NPO, non-profit organization, which means that it's not only good for me, it's also good for the world, for those who care about it. It's a long-standing app. It's been up for over 3 years. It has over 30,000 active users. On its peak hours, it has more than 1,000 concurrent users. And as a backend, I use Firebase, and for the front end, I use Angular, or the Israeli version, Angular. So one morning, like a couple of months ago, I get a phone call from the client telling me that there are some problems with the app. Okay, now since it's on Firebase, it's really easy to just open up the console, open up the dashboard, and get a better look on the situation of your application. Now, I opened this, and it took me a second. You know what, all of you, just take a look at it and tell me what you see, because it took me a while to understand what does the B stands for. You see the B right there? And once I realized we're talking about not thousands, not millions, but billions of reads, I went straight to the very transparent payment plan that Firebase gives you. And I saw the document reads cost about 6 cents for 100,000. Sounds really cheap, right? Like you can buy it for anyone and it would be fine. So I started calculating it, but it wasn't as easy as you think, because first of all, I'm mentally broken. I can hardly type anything. My fingers are trembling. And I tried to type like 9 zeros, right? Billion is 9 zeros, I think so. And the result really shocked me. I found out that in less than an hour, I spent over $7,000. It reached up to $8,000. And I want to show you how. But before I show you how, what do you do? Imagine for a second this thing happens to you. Okay, you open the dashboard, you see this number, what do you do? What's the first thing you do for immediate remedy? So I'm sure some of you are thinking about shutting down production. Now, luckily, Firebase gives you a really easy way to do it. There's like this big red button, shut down the project, but it's not the first thing I do. It's the second thing I did. The third thing I did was to notify the client. After all, they have like 30,000 users to let them know why the app is down. Third or fourth, I back up the project. I want to make sure that I have the data right now, because I don't know what's going to happen. And last but not least, to find the cause, because I do plan to fix it. But the first thing I did, and this is a very important tip, was to cancel my credit card. Let's not let it escalate even further. So let's talk about the root cause. So in broad strokes, a little bit about the architecture of my app. As you know, Firebase is a NoSQL, offers you a NoSQL database among a lot of other solutions, which means that you have collections that store documents. Now, to those collections, you can attach triggers that run on certain events, such as on updates. So once a document in my member collection is being updated, I immediately calculate the price, the membership price. Now, in case the price hasn't changed, then I just break the function. But in case the price has changed, then I'm creating a new document in the transaction collection, a collection holding all the transactions, and I'm creating a new one with the new rate. But same as I did an on-update trigger, I attached an on-update trigger for the members collection. I also attached an on-create trigger for the transaction collection, and which runs another cloud function, a different cloud function that calculates the member's balance. And once it finishes calculate, it updates the member. Now, as you can see, I have potential for an endless loop here, but who needs to worry? I have this breaking condition. What can possibly go wrong? I'll let you ponder about it for a second, but I'll give you a little hint. These are not primitives, which are fairly easy to compare in JavaScript. These are actually objects, and then the plot thickens. Now, I pinpointed the exact line of code that caused it. I'm not sure that all of you can see immediately the problem here. This is the breaking condition. This is what caused all the problem. But as you can guess, we run a tight shift here in Idan Cohen Industries, so I immediately went to GitHub to know who I should blame. And believe it or not, the person I should blame was no other than me from 3 years ago. So don't worry, I fired that guy. He's no longer with us. But before I fired him, I interrogated him about that, the mindset that caused him to write this terrible, terrible piece of code. And it gave me an insight to the inside of the deviant mind of a bad developer. And I came up with some really interesting notions about how this happened. And I wanted to share it with you. You're all great developers. I'm sure you won't do any of his mistakes. But again, it's a good thing to know what he did. So first thing he did was Google it. Who Googles anything? I remember everything by heart. But he Googled something like comparing objects in JavaScript. Makes sense, right? And he came up with this excellent question from Stack Overflow. What is the best way to compare objects in JavaScript? And the first answer gives you the first method, fast and limited. And you probably can recognize this piece of code, which he probably copy-pasted. Who does that? I only write everything from scratch. But if he would only read one more line, he would know that when you use JSON stringify, the order of properties is important. And I went to the logs and I catch the exact moment that this condition failed. I'm not sure you can see it, but these are the exact same object, only the order is different. Here you see the value is last and here is next to last. So if you're comparing JavaScript objects, you should do it the right way. So a few nice tips. First, you can simply use manual comparison. Find a unique property, probably a unique UUID, and compare only those. You can also create a shallow function method that iterates over all the properties and compares them one by one. But if you have an object with nesting object, you should create a deep equality method. But you can read more about it here. Just don't do the same mistake I'm sorry, him did. But that still doesn't explain 12 billion reads. So how did that happen? For that, I have the calculate balance method to blame, the cloud function. What it does actually, and that's pretty trivial, it sums up, as you can see here, this is a query in Firebase. It sums up all the documents in the transaction collection that belongs to that member. Makes sense, right? But if you have a problem in your app and this collection becomes huge, then it would be better, and this is one of the first remedies I did, is to limit this query. Now, 1,000 is obviously an arbitrary number, but there's no viable use case in which a member in my app should have more than 1,000 transactions. So this is a good, let's say, protection. But even a better method to do is to use something that Firebase created for you, and this is an increment command, which allows you to change the value of a property, of a field, without even reading that document. You can just pass the delta, the change, and it would apply it. You don't need to query anything. You don't even need to fetch that specific document you're updating. You can just send the increment command. This is a really nice feature. So if you're aggregating documents and not as stupid as that guy, you should do it the right way. Where are we going? How to use? No. 1 second. There we go. Okay, so deltas are much better than summing up everything from scratch, and always use Firebase increment. That's a really useful tool. You can read more about it here. And so the next steps I did in that specific terrible, dreadful day. So first is deploying a fix, which again, Firebase makes it really easy for you to do. Deploying changes in Firebase is really easy and really nice. I should investigate why the alerts didn't work, because I'm not that, he's not that idiot. He's not that stupid. I did created alerts for a budget and reach out to Google and beg for my life. So let's talk a little bit about the budget. As you can see, I have a budget limit here of 200 shekels, a little bit less than $7,200. But as I found out, budget alerts are about an hour, 2 hours behind. They're delayed. So the email I got from Google Cloud saying that 100% of my budget is reached was sent at 3:59 when the incident, as you can see, ended like almost 2 hours earlier. So if you're doing a Firebase project, there are much better ways to setting up limits and alerts for your project. First, use set up an execution time. There's no reason to settle for the default 60 or 30 seconds. If you have a function that shouldn't take more than a couple of seconds, you can limit its execution time and thus preventing a bad escalation. Even better, you can cap read and writes in Firebase. You can cap memory usage. So if a Cloud Function tries to read like 1 billion documents, for example, you can make sure it won't succeed. You can cap external APIs. That refers to something similar to what the first talk was about. You can use an application like PagerDuty that would make sure that you're up at 2 a.m. when something like this happens. And last but not least, you can write automations. You can write automations that automatically click that big red button. Now, it's not something you want to use every day, but in case of emergencies, this is a really a good way to protect yourself. You can read more about it here. And for the long term, a few tips for those of you who don't want to end up like that guy, write tests. That could have saved me a lot of trouble. Logging, again, Firebase gives you a lot of tools to log events in your Cloud Functions, and that really helped me to pinpoint the problem really quickly. You should limit queries, as I showed you earlier. It shouldn't be endless, no reason for it. You should set up limits and alerts, as I showed you in the previous slide, and you can become a better developer. Failing is an integral part of doing, and when I interview candidates, I'll always ask them about their failures. It's usually much more interesting than their successes, and you can really measure a person about how he by how he grew from he or her mistakes. And last but not least, speak about it, as I'm doing right now, because I'm sure I'm not the only idiot out there. And now when cloud tools and Firebase in specific becomes an integral part of every architecture, this is something you should all be aware of. Now, I want to leave with a nice note. So here's the happy ending. After long deliberations with Google, they were super nice and they were willing to forgo almost 90% of the bill. And the last 10%, I consider this as a tuition fee. I learned my lesson, and hey, it got me here, so it wasn't that bad. That's it. I'm Idan Cohen. I hope you enjoyed. I hope you learned from my mistakes. And if you're a better developer than that guy, we're hiring. Thank you. I'm assuming someone's speaking, but I can't hear anything. Are you muted?
Oh my God, I am muted. Yeah, so thank you very much, Idan. It was a pleasure to have you here, and I definitely learned from your mistakes how to be a better developer. And I just want to remind you, everyone, to just register to our lecture, to our raffle. Sorry, we have really cool prizes. Just register to the raffle. Not a lot of you have already registered, so yeah, it's worth it. Thanks, Idan. You are
Bye.
yeah. Bye bye.
Good luck, Ran. Good luck, Liran. Stay for Liran's talk. He's amazing.
Yeah, Liran is totally amazing. Of course. But yeah, so everybody's saying great talk. So yeah, we have a lot of round of applause here. And yeah, so everybody, just I would like to remind you again to register to our raffle. And with no further words, I would like to welcome Liran Tal to the stage, the one and the only Master Yoda. Master
Hello.
Yoda.
How's it
Hello,
going?
how are you?
Amazing talks today. So looking forward, very excited to speak with everyone.
Definitely. So he's going to talk about finding security and vulnerabilities before they find you. So Liran, awesome to have you here. He's also first of its name. So
That's true. All right, let's kick it off. Okay, cool. So hi, everyone. Thank you for joining us. I want this talk also to be very interactive, so pay attention, and we're going to hack a live app today. So without further ado, my name is Liran Tal. I'm a developer advocate at Sneak, where we build developer-friendly security tools to help empower developers, just build using open source in a secure way. I'm also kind of involved in the, this is like the Node ecosystem security working group. It got a name change. OWASP and some other projects, some other like work around security and web, Node.js and all of those. If you want to ask or join any of this, just reach out. I'm on Twitter or just like, the regular Facebook stuff on the local communities. And with that, let's get this out of the way and, thank open source because it is awesome, right? We have Firebase, open source tools, Angular, React, SES, all of those things. This is amazing. Node, JavaScript, all of this. And I don't need to tell all of you here that open source is growing because, it is, right? I need to update this slide like every day. This is the problem with NPM, right? It's 1.4. Then like a week later, it's 1.5 million, packages today. So yeah, it's growing. Everything else is growing. It's growing. So open source is growing while we do NPM install. That's like how incredible it's growing. So yeah, it is. But really, the question is, like, how much do we really know about the dependencies that we use? And yeah, this is going to be a security talk, but I do want to put some security research articles that I've been reading and have been, I think, super interesting and insightful in terms of what we can learn from them. So I think firing off something kind of like fresh, which I've digged up. Interestingly, we are not the only people asking about, this question of open source supply chain security. Basically, all the open source that we're using and what are the involved risks of using it. So this is the, what is this? This is like the Cyberspace Solarium Commission, blah, 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 whatever. But actually published this in October 2020. So not so long ago. And it was calling out all of this, right? So it's like crying about this thing and, raising the importance of open source supply chain security concerns. And, specifically, they have I've got several quotes out of this, but they have called out that they want to build a center for open source software security to test for vulnerabilities in open source software repositories, which serve as the foundation for most of today's software, which of course we can't deny, right? Because do you remember those times when we used to open the IDE to file new projects and start off from scratch? Yeah, it was nice days, but we don't do that today, right? We do npx create React app or whatever. We build the app from that point on with open source packages. So think about it for a second, because my next slide is going to show you some interesting stats. But another research article, security article I've read from a previous research was looking at the difference between npm and PyPI, and it called out what is the average nested levels of dependencies it adds for you when you do the the average npm install. So what is it, like 1 packages, 2 packages, what packages go in? So maybe you play that numbers in your head, but that research article says, right, on average, you're basically going to be pulling in 4 levels deep of dependencies when you're running that npm install, right? I bet none of us is going to go. I mean, I don't know about you, but I'm not going to go and code review every npm package I'm going to install. Definitely not all of the dependencies it's going to install. So, I mean, that's the world we live at. The other thing that this security research, academic paper thing have called out was this is part of the same paper. So if you want to read it, it's like has some like nice, interesting highlights. The other thing was they called something wanted to like figure out what is the average, or not average, but what is the amount of packages that could be considered abandoned in the npm and PyPI repository. 61% of packages would have been abandoned on npm. That's back to I think 2019 when they ran that research. So still like about 1 million packages, more or less on npm. So think about it, like more than half of the registry. And you could like counter argument this and say, well, maybe the package has reached maturity or whatever. So like, how do they even like decide what is an abandoned package? So they came up with this category that says if the package did not receive a release in the last 12 months, we would flag it as abandoned package. So 61% of packages on npm did not receive a release in the prior 12 months when they ran this research. And like I said, right, you could say reach maturity, feature complete, whatever you want to say, right? Problem is, we got reminded of the event stream incident, which Mark Miller on his, in the first talk here on this meetup, was actually referring to, right? This, to my opinion, probably one of the most significant attacks or incidents, security incidents, if you'd like, on npm on JavaScript that we've seen. Because walking basically like very shortly on since we don't have a lot of time here, and I do want to do some live hacking, but walking very shortly on what happened, right? So event stream is a package owned by Dominic Tarr, member of the open source community and npm, and this specific package existed on npm since like 2011, so like almost a decade. I did not hear about it before. I'm pretty sure you did not either, because it's not really used as like the main direct package that will add to package.json, but it will probably be used by things like React, maybe like Webpack, part of like this the downstream dependencies. So it practically did not receive any release in the last 2 years. But suddenly, a person shows up and says on the GitHub repository, hey, I want to help. They open an issue, they want to help. Of course, they follow up with some pull requests, more pull requests and all of those things. Then they eventually go ahead and create a pull request that adds a dependency called FatMapStream into event stream's own package tree, because why not? I mean, this is npm and it's modular and it's JavaScript. Why would I not, reuse that in my other projects as well? So this went well, and they did receive, that kind of contribution merging in. And at that point of time, Dominic also said, he's a person of, doing a lot of open source work, and he's not short of doing open source. So I has like, maintain like 400 or whatever other modules on npm. So, why not let this person who has kindly stepped in to help me, work on open source, manage this project? So kind of like this is how they socially engineer their way into event stream, a package that gets downloaded, millions of times a week, and being able now to influence this entire dependency tree by basically adding a new dependency that they control. Of course, when they added it, it was just fine. Didn't really do anything except what it was supposed to do, except, a version later, it did something more malicious. It actually targeted Bitcoin wallet application called Copay, but not really the Bitcoin wallet application. It actually targeted us, right, developers using it, because they understood how the build process works, and the fact that event stream is part of it. That's why it actually targeted event stream to begin with. And since that Copay app is working, being developed out in the open, in the public, they could figure out all of those things, just doing a little bit of like open source intelligence and figuring out how things work. So yeah, this kind of like went unnoticed for like 3 months, ended up with several versions of Copay being deployed, having the malware. I've seen some people, basically some companies that I know about that are like, until today still have, remnants, right? So it has like, they have like a flat map stream or event stream basically as part of their dependency tree in some projects. So I don't know if that's going to be for something useful, hopefully not, but that's the truth. So here's a mental exercise, right? You imagine you're building an application, Node.js or whatever, or something maybe else. But your mental image is really that, end diagram, right? Is that end blob, your app. But what I'm really kind of like advocating here and trying to bring the awareness of is, well, the app that you write is actually a lot larger, right? We bring all those dependencies that help us, build what we need, but our code is like, usually, a small percentage of that, and that's okay. We're using open source, but we should be aware of all of those things happening so we can be ready to mitigate them. We can be ready in the way that we need to, watch out for them, monitor them, whatever, all of those things, fix them, rush with upgrades, whatever we need. So one of those things that make it really hard is the fact that security vulnerabilities happen in open source packages very differently in the way that they manifest between different ecosystems. So what this basically means is this is part of the state of open source security research that Snyk annually puts out there, is the fact that in NPM, for example, right, the majority of the times we find vulnerabilities for users using Snyk, it's in the indirect packages. Right, so it means if you're basically looking at all the change logs and announcements and code reviewing all of your direct dependencies, this is great. But most of the time, we'll find vulnerabilities in those indirect vulnerabilities, indirect packages, which you should be aware of. And you see that it differs between different ecosystems, and it's an interesting, I would say, a question or so to figure out why is it, which I can kind of like stipulate, but we'll skip that. So, there are different kind of vulnerabilities and incidents that we should be aware of. My favorite kinds of things to talk about are the malicious packages, because they are kind of like, the juicy, interesting, stories that we can learn from. For example, what could go wrong with installing get cookies or any of these other packages here. And by the way, there've been like, I shall really update this slide. There's like 2019 and 2020 related, also 2021 malicious packages incidents, but we'll focus on get cookies specifically. So if you wanted to say use and parse your HTTP headers, cookie data or whatever, manipulate it, read it, write it, whatever, you might be willing to install get cookies, which is a package that kind of does that. It does, but it does a little bit more, maybe a lot more. It's basically nothing less than a command and control backdoor that once you installed it, it exposes this through this express middleware that allows remote code execution and injection to any Express app that bundles this and uses this. And how does it do it? So there are like a proof of concepts of these codes, remnants out there, just because people try to keep track of what was going on there. But basically, what happens is it has it serves out three different commands for an attacker to kind of use this. One of them is clearing the buffer, then loading data into the buffer, which is JavaScript code that we want to do there, and of course lastly running this code, executing it on Node, which is easily done at the end. But of course to really push this in, we can hide it in several layers, which is what they did. They actually added added several levels or layers of dependencies to hide this malicious package. But at the end, who's going to install HTTP fetch cookies, right? If it has 0 downloads or 10 downloads or whatever, just bots downloading it over the internet is tens or something. So let's find the more interesting story here. Maybe let's try and compromise mail parser that has 500,000 downloads a month. Get HTTP fetch cookies as part of that dependency tree, and of course the entire dependency tree kind of gets all of the downloads and all of this. And yes, there we go. We have tons of downloads. And now the next time that I'm going to go into npm.js or whatever to search for HTTP fetch cookies, and I have something that gets downloaded 500,000 times, now HTTP fetch cookies or a library called express cookies doesn't sound so bad. Maybe I'll use it. It's at least 500,000 users other that are using it. So why not? But all of those stories are, they usually, don't affect us. And, even if you had installed the malicious version of EventStream, which is, by the way, the EventStream is not a malicious package. That's just a version of it that got, been malicious because of the dependency tree it brought in. But, even if you installed the malicious version again of EventStream, nothing would have happened to you because the specific payload had targeted, a specific state and all of those things. So, those malicious stories are interesting, but they're not the real thing. And we get all of these other vulnerabilities, like SQL injection in SQL, in SQLize, or typo and prototype pollution that, I can, demo a lot of SQL injections related to. And they're always happening, right? This is like the boring set of vulnerabilities, right? Markdown to JS6, almost 1 million weekly downloads. And the fact that you're using secure React APIs, like not to use dangerously set inner HTML, hopefully, it doesn't mean that other developers or maintainers or contributors down there somewhere in that dependency tree or graph know not to do it either. Or maybe they know, but there's a regression or whatever. So again, it doesn't mean that you're secure if you're just using React, because if you use this one, you're insecure again. So this specific version. Well, how do we go from basically the dependencies and the vulnerabilities in them to the application vulnerabilities? Because that is not always a straight line that we can draw or understand how that works. So for that, I'm going to move into an actual demo that we have. Let's see if everything working here. We'll zoom in a bit. This is a nice to-do application, which this is where I need you to add comments in the chat, which I'll monitor to have the interactive parts here. So you see there's a couple of things here, like buttons, whatever. There's some input. I could say, hi, JavaScript IL, and all of those things. And, tell me what you would try. What would you go ahead and try to basically, exploit this? What would you try to put in? So while this is not a full interactive session, which I'll accept, I'll go ahead and guide this through. So maybe I'll go ahead and try some XSS, like cross-site scripting, which I could maybe, inject some JavaScript here. So things as simple as this, right? Let's try this out. What do you think? Gonna work? Not gonna work. This app is entirely JavaScript. I have this var, right? Everyone is laughing right now. This is working out. This is a Node and JavaScript all the way on the front end as well. So this didn't really work. And what I had wanted to do more on this is also basically to make this support Markdown. So I could do things like hi, JSIL or something like that, and then it gets into being bold. Now the thing is, this kind of strong type of font here didn't really happen just the way that it is. It's happened because I'm using this marked, which has several vulnerabilities here, obviously, because this is potentially deliberately vulnerable application. And I wanted to add this markdown, which of course I did not write myself, so I used marked. And let me show you on using the Sneak Advisor to look up marked, and you see marked is 5 million downloads. This is a pretty big project. So it's very popular, very well maintained, all of those things. It had, interestingly, it had some security vulnerabilities, even direct ones, not just direct and high, not just direct and mediums. Just recently, it's what is this, March or February, just then. So, well, I'm using marked because I'm not going to write my own markdown parser. So I can go ahead and do things like this. This is the JSIL website, for example. Create links, which works and probably won't lead me anywhere, or I will not try this now. Who knows where this brings us? But this brings another interesting kind of attack vector. Maybe I can use the alert, or calling JavaScript via, I don't know, maybe links, right? This pattern, right? Which is, by the way, vulnerable if you use React, because React doesn't, at least not the latest version, or at least not the one that I've looked at, which was pretty recently anyway, does not filter this out. So theoretically speaking, if you're putting any props or whatever values here from user input, this will get in, and that could potentially be JavaScript, colon alert, that would have created an XSS. So unless you're not doing this and filtering that yourself, which is a good idea, that could have happened. So yeah, well, let's do something like this here. Let's do something like JavaScript alert. And what's happening? Let's see. Let's try it out. Okay, so it did not really work. It broke kind of in a whatever broken way, which is interesting. So why did it actually not work? Because for marked, when I initialized it, I actually had to pass in this sanitize true option. So basically, I told Mark that I do want it to sanitize all of those strings. By the way, this is not a default. So if no one had told me, if I did not read the documentation or anything like that, or maybe just missed it, I would have basically used marked. And in that version, it was default to insecure because it allowed all of those things to basically work. So hopefully someone knows this, and we do have sanitization true, and that's why this doesn't work. Now, what would you have tried next? What would be the next thing that you try to maybe create, an XSS here? This doesn't really work, and we can figure out why it doesn't work, right? Like marked is open source. I can go to the GitHub repository, look at the tests, look at the code, and figure out why this doesn't work. So the reason it doesn't work is the fact that there's a regular expression that says, look for anything JavaScript, colon something, and it just fails right there. So what if I represented part of this in a different way? What if I used my knowledge on maybe the way that the browser or HTML is constructed can use things like HTML entities or something like that, right? I could use something like what is it? Is it like this? This is an HTML entity that means a colon, and entering the chats during this. It's something about injecting a script tag. And maybe this would be 41. If I remember those correctly, let's see what happens there. So this doesn't yet happen. This does not bring us into a proper state of an XSS. And it's to no surprise. It's because we basically enabled this sanitize true, which what it did was it sanitized this as well. So the maintainers of Mark were actually very, I would say, security-minded and conscious. I mean, not the default stuff, being turned off with security turned off, but at least here, when they needed to sanitize the input strings, they understood that potentially someone could bring in this kind of HTML encoding into this input. So yeah, this didn't really work. But there's actually a deeper story here of what could happen, and that is there's a regex probably checks for all of those kind of like prefixes, characters, and then numbers, and signs off with this semicolon and so on. But what if I had a way to kind of like bypass the sanitization, yet the browser would kind of like add this the way it is? So what if I had put the word this here, like literally, I know this is confusing because we're all JavaScripters here, but literally the word this. And what would happen is, well, this is not a valid HTML entity. So at this point, it bypasses Mark's own validation, and that's why Mark doesn't do anything with it. But let's try it out. I'm just gonna show you. Okay, so this is why it's actually showing us and just like killing the tension here. No cliffhanger. This is an XSS in Mark. But why did it work? Right? Because anything that I'd put here, like document or whatever, would be a valid JavaScript statement if I could type for the life of me. Document. I think that's spelled correctly. What happens is while it bypasses Mark, it doesn't bypass the browser. The browser basically just says, well, I think you meant to like close this with a semicolon. The rest of that just becomes, legal legal HTML. And so this is really why this is happening. But let's talk about it for a second. What was going on with Mark? Because remember I said there was not a lot of interesting stories around open source, but specifically with open source, vulnerabilities, the regular ones that KSSCV is. But some of them are interesting. Okay, some of them are intriguing in the way that they actually work. So marked, for example, you see it was merged. When someone opened this vulnerability specifically out in the open. So first of all, someone basically created an open source a pull request, like publicly. At this point, May 2015, everyone knew that Marked had this vulnerability. This is a POC, proof of concept. This is how you do it, right? This is an amazing PR because, whoa, there's even tests and validation. So there's like no regression. You actually fix the problem, not just say, hey, you have an XSS, deal with it. Matt Austin is a great researcher helping us basically, solve the problem here. The only problem with this whole thing is, as you remember, we're working in open source. So there is no real urgency for anyone to kind of like merge this. That's why it's like +1 vacation for a year must be nice, because the actual truth is that this only got merged and released a year later. So 4 million whatever amount of people downloading this, back like a few years when this was happening, all were actually vulnerable at that point. This was like public knowledge, and with no fix, right? No fix of how you could do it. So this is my story of Marked, and I, being conscious of the time, I see we do have a few more minutes, so I will show you another vulnerability in my app here. Let's go back to the app. There we go. Okay, so what else can we do here? There's a couple more. Let's try about. Well, how about we do not a path traversal one, but something like more interesting. See if we do a backend one. We did front end. It's only fair we do some backend here. Okay, so I am using Dust.js, which is a template engine, which is, some of us use EJS, Plug, all of those things. So here's the template engine. This is the way it works. You define a view, kind of, and there's some conditionals, obviously, which allows you to do some logic. This is why we render it on the server, and then give the results to the client. So this is my simple logic. If device equals desktop, render this, otherwise render that, and this is what we're bringing back to the browser in the request. So this would be something like device equals mobile, and it should be big. And if it's anything else, basically like desktop, it's small. See, this is mobile ready already. JavaScript IL. Cool. So at this point, let's see. Dust has some vulnerabilities. Going back into what I scanned. So my version of Dust, scanned it with Sneaker, and obviously, and it has code injection. The code injection, right, with really big, score for priority. So what should I do with this now? How does even this work in terms of, what's the actual vulnerability here? So let's think about it for a second. First of all, if we think about the route of, well, how do we exploit this? Then this is user input, right? I've just showed you how this template receives user input. So device equals mobile, that's an input. And I could do several things, like maybe, I don't know, let me try to do quotes or single quotes, but looks like it's treating them okay, escaping them or whatever. So that doesn't really work anyway. What else could I do? Any ideas on the chat are good, but again, for the being conscious of time, I will move forward here. So let's see what's going on with the Dust code base. So if we go into the Dust code base, there's one of Dust, was when it was developed as part of like an entire, bigger framework called the Kraken. It's back then, the min stack days, 2014, 2015, everything was cool around JavaScript. It's cool today, but it was cooler then. Maybe, I don't know, whatever. So what's happening is it wanted to be secure, this whole thing. So you see this like escape HTML. I'll zoom in a bit bigger so you can see it. It had, default escaping of all of those things. There's only one bug here. Only one bug. Do your own code reviews. Look at it. See if you can find it. What's going on? Looks like if something is a string, it's going to test it out. It's going to, replace all of those single quote, whatever, less than, all of those instances of things like that into basically HTML entities, which is, what Mark did before as well. So this all looks like it's good, right? It looks like it's okay. Except, what if something is not a string, right? What if it's not a string? Then we do not go inside this case. We return whatever string is brought to us without sanitizing it. Interesting. Well, when is this not a string? And this is my input. This is mobile. When is this not a string? If I do want to create, is that like a number? Or is this a string when the request parameters, whatever query object reads it on Express? What is it? I don't know. But I know a fact where I can actually influence this type to not be a string for sure. And that is anything on the comments? Not yet. Okay. But that is, I'm going to take this to the CLI so you can do it here. Go on. There we go. So let's try this. There we go. I'm gonna try one request. Looks like it's just doing its thing. Nothing precious going on here. You can try giving it different inputs. Again, not doing anything out of the ordinary here. Consider request being served here. But what if I try representing device as an array, like giving it its brackets notation, and then I try to do some things? Well, first of all, nothing, again, out of the ordinary happening here, because this is just fine. But the moment I try to do different things, like maybe I kind of like try to kind of like mess up with what's going on there. Oh, look at that! I am getting this error page, right? Syntax error, unexpected identifier. Object if there's like a whole stack trace here, Liran Tal projects, repos, whatever. I can see the server crashing here, whatever. This is not really working well for us, and we have understood now that there is an attack vector that we can do. So what if I had went in and did? Well, I need to see the code, right? If I had went in and basically tried to escape, try to escape this if case. Because this if case, this is the helper that helps us basically do these kind of things. So you can see that this is a condition that we move over, and this helper is basically using eval, right? Eval on the server side to do evaluation of the condition itself. So at this point, what I could try and do is basically influence this by doing something else. I could try and maybe break out of, let's see if this works. Break out basically of the eval statement by appending all of this, and then console log 1 runs. It doesn't run here. It doesn't run on the browser because this is all server-side evaluated. So it runs on the backend. So this is a way that I could actually do code injection on the backend based on the fact that this app is just using a vulnerable version of Dust. So all of this is happening basically due to this. Let's go back here. Hope you learned some new things here. So AppSec is challenging, right? Application security is challenging because why? Well, let me tell you why. This is the top 10 US computer science programs. And I stole this thing from like a DEF CON slide. Someone was showing this, and he said, well, I'm now filtering this to all the universities or whatever the science programs, the CS programs that actually require that you pass an InfoSec training. What do you think? MIT, Stanford, go ahead. Which one stays on this list? 1, 2, 3. This is it. None, right? Because, well, AppSec is hard, right? There doesn't say that there are now not any InfoSec or AppSec trainings there, but these classes are not mandatory to basically finish off CS, which, as we know, like a lot of other things, like being, an expert on CSS, which I'd love to be able to do, but there's, this was not a mandatory skill for me to graduate university from. So I'm not. I suck at CSS, but whatever. So there's like a ton of AppSec related best practices in terms of different, Java, Spring Boot, whatever, Express, Angular, React, all on the Sneak blog. If you have any questions, I'd be happy to take them and help you code securely. So this was me, and back to you. Hey, Tamar, you're back. And muted again.
Alon, you have to stop mute me. Thanks a lot, Liran. It was an amazing talk. And let's see if we have any questions. Yeah. I think so. Let me say, guys, yeah. Most of the time, developers write code they may not be aware has vulnerabilities. How as a developer, I can avoid that?
Great question. Several ways. Linters. So this is just to frame the question. This is a question on first-party code, not using dependencies, which is a great question. So how can we write better code and not an insecure one? So one way is working towards best practices, like Angular has this best practices security thing. Node has, if you read the documentation for like, the Node APIs, if you're using exec, it's bad, and it tells you, be careful. If you're using exec file, it's, a little bit better because you are reducing the attack surface and the attacker cannot control the executable. So many things. The other ways of doing this is, of course, linters. Like beyond the documentation, linters is a good, fast way. Not a really large ROI because it's a lot of noise and it's very rigid. You can't really tune it to what you need. The evolution on that is basically, beyond, code reviews, documentation, best practices, all of those things. Beyond going into tooling, the next best thing are SAST, basically static application code analysis, which is something that reads the code, tries to understand what's a source, what's a sink, basically, what's an input from like a query program going back into your, SQL injection or something, SQL query, and creating an SQL injection. So these are SAS tools. I actually have some of it here, like when I added my project. Sneak has this, we just released it, so this is like pretty new, but when you import the project, we basically, add it from GitHub or wherever you want. And at that point, we kind of like understand what's going on there. So code analysis is part of it, and it helps you find all of those issues, like XSS, command injection in your app, and this is all in first-party code. This is my, if you scan the goof up, which is what I use, which is open source, you could see it. So you could go and choose, whatever SAS tools you want that work the way you want, and this is, the next best step to automate this process and help you fix those problems. Great question.
Amazing. So let's move on to the next questions because I see here you. Well, yeah, another question. Can you provide any reference for best security practice to avoid vulnerabilities? Oh, yeah, we've already done that. You
Cool,
can repeat that if you want. Any more questions from the crowd?
You're welcome to also ping me afterwards. Happy to chat.
Cool. So I don't think we have more questions. We just give you a round of applause. So thank you very much, Liran. It was a pleasure to have you here.